Good morning once again, folks. This is the first of our breakout sessions in this area. Our speaker is Alexandra Birch, reader in natural language processing at the University of Edinburgh and chief scientist of Aveni AI. We finished off the last session talking about AI. It is the hot topic at the moment, so I'll put you straight across to Alexandra.
Thank you, Mark. Hi, I'm really pleased to be here. So I'm going to talk about conversational AI. It's already a very established industry. We have dialogue systems that are widely deployed across different sectors. These are dialogue systems which can do very task-specific but useful things, like, for instance, book a hotel. And we can see that traditionally these kind of conversational AI tools have been constructed with a pipeline of natural language processing tech tools. So we've got natural language understanding, dialogue state tracking, policy learning, and generation, and they all work together. But what tends to happen is that actually they're quite brittle, and errors can propagate through this pipeline. And it takes quite a lot of time and effort to tailor and create one of these systems for a particular use case. And even once they're deployed, they can be quite unnatural and brittle. So really, what we now have, thanks to generative AI, is the promise of kind of a new era in conversational AI tools. These tools can be deployed. One of these language models can really understand and generate across many different use cases and sectors. And it can also be far more natural, and it can deal with really complicated tools, sophisticated tools, and interact with, not just, say, one specific database, but it can be used and trained to be able to interact with tools such as Adobe, or with robots, or with driverless cars, or maybe even interfaces to very large, sophisticated databases used through something like SQL. So these tools really promise that not only can we interact with the world and solve problems through a natural language conversational interface, but that this becomes actually quite easy for us. We no longer need to be experts in Photoshop to design a logo. We no longer need to know all the commands to create a plan for a robot. Or we don't actually need to know sophisticated, complex SQL commands to be able to extract the information that we need from databases. So it not only unlocks the ability to do these things, but also makes us be able to do these complex tasks very easily. But one thing that's really important to note with conversations is that conversations are interactive. So through a series of interactions with a tool, what we can do is initially we can ask the tool to, say, write an email, but that's not the end of the task. In fact, it's just the beginning. Maybe it gives us a proposal, an email like this, and it's not quite right. So what we can do is actually interact with this conversational agent, and we can give it further instructions. We can make more specific suggestions. We can, ask it to try something different, and thereby we have this sort of interactive process where together, we can generate something that's truly fit for purpose. But again, through kind of a conversational interface that's easy as a human to drive, and so the conversational agent becomes not so much a tool, but like a partner in the creation of these kinds of outputs. In this case, an email to a customer. And of course, this has become much more realistic. It's no longer such a far-off dream, this dream of sort of universal conversational AI interface to all of our sophisticated tools, thanks to generative AI. So as we all know, ChatGPT was released at the end of last year, and it's caused a huge change in the way people think about innovation. It's been the fastest ever adopted tool application. You know, it's 4 times faster adoption than TikTok, which is really astounding. But it's not just as an application, you know, to try out. I'm sure a lot of you have its capabilities at home. It is now also being very widely adopted across pretty much all industries. So as a researcher in natural language processing, I thought it would be interesting to kind of discuss a little bit about what actually is generative AI. And machine learning has obviously got a long history, and it can be basically divided into these sort of 2 types of models, discriminative and generative models. And they're quite different. So until very recently, we've all been working most of the time, say, with discriminative models, where what we have is we've got labeled data. So we've got pictures of dogs or muffins, and then we have labels attached to those images. And this data is quite limited. It's expensive to create. And we can get high-precision models sometimes, most of the time. And the models are trained to define the decision boundary between the 2 classes that we've labeled. So these models are pretty useful and exciting. But generative AI is quite different. So the idea here is not to model the decision boundary between 2 classes or 5 or 100 classes. The idea with generative models is that we're trying to model the underlying data itself. So the data that we have isn't labeled data, it's unlabeled data. So the great thing about unlabeled data is, of course, it's far more plentiful. You know, we can access millions of images, and in our case, we're probably more interested in millions of sentences of text. And thanks to recent advances in natural language processing, deep learning, and compute power, we're actually able to now make these generative models truly useful because of the scale of the size of the models and the size of the training data sets that we can access. So what I'm going to talk about mainly today is generative models of language. So how do we model language in a generative fashion? We train up a language model. So language models were kind of these sort of toy models that in natural language processing you would study as a kind of interesting thought experiment, but nobody really imagined that language models would be useful because what they do is they just predict the next word. So if you're given the word "the," you can imagine all sorts of, you could have thousands of possible words that could be predicted after the word "the." There's an enormous variety here of choice. But say in this particular case, we choose to generate the word "best." And the language model then learns from data that, after the "best," maybe the word "things" appear, and then "in" is likely, and "life." And at this point, we're all pretty certain what the next word kind of has to be. There's not as much entropy there. The word "freeze" is probably most likely. So this seems like a very simple task. But even though it's very simple, it's very powerful because actually the simplicity of it means that you can train it on vast amounts of data. You can train it on English. You can train it on other languages. You can even train it on programming languages, such as Python or Java or something. So these are generative models of AI. This is ChatGPT, and it's very simple. And the question is, how does it work so well? Well, the fact is that if you're able to predict the next word, you have to have a really good understanding of what those words mean in that context. And really, that's really essentially what we've done, is we've trained a model to get a very good understanding, not just of words, but of sentences and documents as well. And if you think about it, actually, understanding language is the key to solving very complex problems. So with language, you can describe a problem in any way you like, a maths problem, an ethical problem, and then the solution can also be described in language. And you can describe it in language, but you can also describe it in a way that could be used by tools as instructions. So you can not just kind of generate text, but you can generate instructions for complex tools such as robots and Adobe Photoshop. But these models clearly still have problems. They're not, we've made huge progress, but we haven't quite got there yet. One of the things that these models do is that they hallucinate. So they generate content or facts that are just simply not correct. This is sometimes what you want the model to do. If you're asking it to generate a poem or a story, then actually hallucination is a feature and not a bug. But in other cases, you really do not want hallucination. We have to discuss errors. These things make mistakes, so sometimes it's not generating factually incorrect data, but it's answering questions incorrectly. And this could be because it doesn't understand the question. Maybe you've given it some complex instruction and it's got it wrong. These things don't work perfectly. The other thing is that they're trained on vast amounts of data, generally from the internet. And of course, that data contains very strong biases. Biases that can be sometimes even discriminatory, biases against certain minority groups or certain genders. And these are things that can be very dangerous when used directly in applications. Also, in this pile of data that it's trained on, of course, there's toxic speech, which we don't want it to generate, and also unsafe information. Potentially, it can learn how to generate, to build a bomb or make a poison or something like that, which we don't want the model to generate. And also in that pile of data, there's actually a lot of information about people. So, maybe you ask it when was Donald Trump born, and that might be fine. The model's learned that it's a public figure, it's not dangerous. But if you ask about private individuals, it might actually know things about private individuals, like their political affiliation or their address and phone number even, that you don't want it to reveal. So these are all risks that need to be taken into account and managed when using large language models. So predicting the next word gets you really far. The models absorb a huge amount of knowledge and understanding of language, but they're actually not very good at following instructions. So in order to really unlock the capability of these large language models, what you need to do is create a labeled training set of instructions and outputs. So in this case, for instance, we've got 2 prompts where we've specified what we want the model to do, write a 500-word essay on customer engagement, and then we provide it with that 500-word essay. And you train the model as a kind of next step on a kind of supervised setting to generate these outputs. And this makes the model far more performant. But another thing that it does is that you can actually introduce prompts that will allow the model to align better to your values. So if the model has learned in this a vast amount of data, say some sort of bias against homosexuality, for instance, which it could very well have picked up, in this training set of instruction fine-tuning, you can add prompts and instructions and outputs that will fine-tune it to be far more likely to output fair and unbiased opinions about things like sexuality or race or gender. And you can also encourage it not to explain to somebody how to build a bomb. So looking at a little bit more detail about this idea of knowledge representation. So we rely on models to answer our questions, and sometimes those questions are asking about basic facts. And the way that the model stores knowledge is they're basically these vast mathematical functions where they're these massive matrices full of real numbers. And basically, knowledge gets stored in these matrices, in these numbers. And it's very opaque. We don't know where the knowledge is stored. We don't know how the knowledge is stored. We don't know if it's reliable or not. But enormous amounts of knowledge are, in fact, stored in the parameters of the model. And questions that are sort of maybe quite common knowledge, for instance, what is the capital of China, you'd expect that the model could actually answer this question quite reliably. But if we're wanting to really nail it and make sure that the answer is correct, what we could also do is we could get the model to actually get this knowledge from an external source. We could get it to ask a database this question and we could write some SQL and get the capital that way. And it would be far more reliable, generally, if we did this. If we're trying to ask a question like, is this customer vulnerable, what we actually want the model to do is not to use its knowledge of the text from the internet, but actually get this knowledge from, say, transcripts of conversations with particular customers. So we're wanting it to access external, unstructured data to answer this question. And obviously, there are other questions like, what is the Bank of England base rate? These are questions that every day might change, and so you're wanting it to actually look something up because the latest information won't be stored in its parameters. So this idea of parametric knowledge and non-parametric knowledge is actually quite important. We just published a paper last week looking at how reliable is the knowledge in large language models. And we took a database of facts. So in this case, I'm using an example of the location factor, what cities located in countries. And we asked it, for hundreds of examples, we asked it the question. We actually asked it in two different ways to predict the next word. So Beijing is located in, and then it had to provide a country as the next word. Or we asked it as a question, which country is Beijing situated in? Now, humans would expect to have exactly the same performance on these questions. When we examined, in this case, we can see 6 different open source large language models of different sizes from smaller to larger. We see that depending on the type of question, the format of the prompt that we gave it, the accuracy of the knowledge that these models displayed was actually really different. I mean, in the case of Galactica, the question answering prompt was about accurate 50% of the time, but the word prediction prompt was only accurate about 5% of the time. That's a massive difference. So you can see the model's actually very sensitive to the type of prompt, the actual prompt used. We can also see that as the language models get bigger, they get more and more accurate. But as a business thought leader, you might not be comfortable with this kind of performance, actually. They're still not 100% accurate. So we might, in fact, in this case, try to use a database instead of relying on the parametric knowledge in the models. So the way to use the non-parametric knowledge is to use retrieval. So we actually access, the user asks a question, and then we change that into some kind of query, which could either be a SQL query or could be information retrieval task, searching text or a data set for answers. We then take the answers and we provide it as context to the prompt to GPT or another large language model and provide a response. And this way we can make sure that we have the latest information from the sources that we're wanting to use. And we can also see if, with the answer provided to the user, where that answer came from. So we can explain the answer. So retrieval augmented generation is a fantastic way to provide more reliable knowledge and more explainable knowledge to the user. So I just want to quickly discuss a few examples of conversational AI in practice. We obviously still have a long road ahead of us, but in Aveni we have been developing some exciting products and also demos of possible products that I thought would be enlightening. One of the exciting applications of these models, obviously, to improve customer engagement. So if we have conversations, unstructured data from transcripts of conversations with our customers, we might want to ask a question about our customers. Is the customer vulnerable, for instance? And if we wanted to do this before with the information extraction pipeline, we would have to have a lot of labeled data to answer this question. And it might be quite brittle to new domains and new types of customers. With generative AI, what we can do is we can just directly ask this question and see how well it performs. If it doesn't perform particularly well, we can actually we can add more context. We can actually define what a vulnerable customer is before asking the question. And this way, we can really very quickly develop a product where we can reliably answer this question of, is our customer vulnerable or not? And we're exploring a number of different things to make this far more, to really realize the potential of this kind of understanding of our customer. So one thing is to have an automated way of searching through prompts to see which of these prompts are more performant or not. We also have incorporated this idea of human feedback. So experts will look at the answer of these questions and say, is this correct or not? And then we can use that to improve the model. And also, we're looking at the best ways of using this kind of information to then feed back into marketing, direct emails, and also suggesting maybe personalized products for these kinds of customers. So we can ask all of these, a wide variety of these kinds of questions. What does the customer want? Did the customer express dissatisfaction? What did the customer complain about? And this way we can the picture of our customer can really emerge. We can really get a much better idea. And with that, we can produce reports. We can detect problems with particular products. And we can deliver far better customer engagement for our business. But these answers, as we said, could potentially be incorrect. So it's very important to think about what kind of guardrails do we put around these large language models. And the most important one is that every time we answer one of these questions, we need to show where in the conversation that information has come from. So we not just answer the question, but we provide the location in the conversation where the answer came from. We also have a set of other tools, other machine learning tools and search functions that we put around it that we know are high performance and reliable. And in combination, we can have a better trust. We develop better trust in the language model outputs. And of course, testing is really important, and having a large set of real-world use cases to make sure that performance is up to scratch is very important. The other thing we can do is not just improve our customer engagement, but we can improve the efficiencies of our processes. So in Aveni, we've developed Aveni Assist, which is a product used for financial advisors. The idea is to reduce the vast amount of time that takes to process customers after having a 2-hour meeting with the customer. The amount of paperwork and emails generated afterwards it takes hours. And with Aveni Assist, what we can do is we can instantly process the transcript of the conversation and do a lot of automated checks to reduce this time to process a customer. And we could detect things like, for example, that we didn't have their postcode for the CRM, and we can generate suitability reports and emails for the customer. And this cuts down, it increases advisor efficiency by 2 or 3 times. Again, it's very important to think of the guardrails. Every time we generate an email for a customer, we also provide why we suggested these particular sentences or paragraphs and where they came from in the original conversation. And we have the financial advisor still makes sure, reads through that email, checks that it's correct before sending it. As a demo, we've also delivered an automated advice product, which is a dialogue system that uses large language models. So if the customer asks, hi there, can I get my bank balance? The advice, the dialogue system will reply, sure, what is your customer number? And the great thing about this dialogue system is that it has a much more natural interface than the traditional conversational AI products. And although it's really good at interacting with humans and continuing a conversation and taking context into account, we also need to make sure that it's correct. So what we do is, the guardrails in this case are, we ground this conversation in a dialogue tree, a pre-specified dialogue tree, and we make sure that every utterance of the customer, we know what their intent was and what the slots we need are for that. And we found that this system actually can follow the correct path in a dialogue tree 95% of the time. So what is the future? Research is moving incredibly quickly. It's very hard to keep up. There's some clear trends. One is that these models are no longer focused entirely on text, but they incorporate other modalities like speech and images. Also using the reliable use of tools in integration with these language models is very important. Using autonomy, so using models to improve themselves, is another area of great interest. And how to use these models safely is really important. So it's really important to understand the potential for these models and how to integrate it to create transformative products that people can trust. And the take-home message is that there is really a potential for transformation of the way that we work, because not only can these models do things that we couldn't do before, but they can make it, the way that we do them can be made so much easier as well. If you can say it, you can do it. And that's really, really exciting. Thank you.
Thank you.